Hello friends, now we will see the independent sideband system. Try to write some signal value, suppose 100 Hz, okay, and here signal 2 will consider the value as the 200 Hz. Two different audio frequency signals are coupled to, first signal is coupled to the channel A AF amplifier, second it is coupled to channel B AF amplifier. Both signals are coupled to separate balance modulator. This is balance modulator 1, this is balance modulator 2. Balance modulator is again powered by 100 kHz crystal oscillator. Frequency of 100 kHz is coupled to the balance modulator. So both balance modulator have the 100 kHz carrier frequency. Now output of balance modulator, we know that DSB SC output we are getting. Here also we are getting DSB SC output, okay, and it coupled to the USB filter where LSB will be heavily attenuated and only USB will be allowed to pass through it. Here opposite case to that of the upper one, that LSB filter allowed to pass the LSB and USB will be heavily attenuated. So it is coupled to the adder. Third input to the adder is nothing but the derived from the crystal oscillator frequency, 100 kHz crystal oscillator frequency. Here 26 dB carrier oscillator it is there. Means what? 100 kHz frequency is attenuated at a rate of 26 dB. This is actually called as a pilot carrier frequency. Here pilot carrier is nothing but the frequency, pilot carrier frequency will be remain present along with the information up to the receiving end, and this will improve the quality of the received signal. But why this pilot carrier frequency required? The pilot carrier, one thing related with the carrier frequency, that double sideband, even though we are calling it as a double sideband with suppressed carrier, carrier cannot be completely eliminated, but you can suppress that carrier up to a higher extent. So here the carrier, it is suppressed heavily and sent along with the information signal. It is coupled to the balance modulator synthesizer, which is inputted by 3 MHz crystal oscillator. Actually synthesizer is nothing but it can generate more number of precise frequencies from a single reference frequency. Frequencies directly you cannot multiply, but you can divide the time period to get the desired frequency. So same concept is applied here. So 3.1 MHz crystal oscillator, it is coupled to the balance modulator. So here the signal, it is coupled to the balance mixer. Balance mixer which is having frequency 7.1 to 26.9 MHz synthesizer. That is from the synthesizer output. So more number of the precise frequency will be supplied to the balance modulator through buffer amplifier. This frequency it is generated by this, and it is sufficiently boosted by the buffer and the amplifier. Buffer and amplifier means buffer, one type of buffer can improve the driving capability of the circuit of the particular device, and another is amplification. It is coupled to the balance mixer. Output of balance mixer, this single sideband component will be present, and it is coupled to the linear amplifier and transmitted through transmitting antenna. So this transmitter unit is transmitting the sidebands independently. Here actually one duplexer unit need to be deployed at the transmitting antenna. So this was all about the independent sideband system.